Hi, Marie Curie. It's Ms. Cooper. I'm in the class, actually the lab room. I'm in here. I'm just trying to give you some pointers for the homework number 4. Some of the students are still having problems because they don't know the nucleate. So here's the nucleate. Here we go. We look here. These are all examples of atoms that have the ability to emit particles, and these are your particles here. When we talked about the types of radiation that can be caused, this is half-life, how long it takes for it to happen. We have seconds, minutes, years, and so on. Then this last column is the nucleate, the name. So if you forget gold 198, there's gold 198. Carbon 14, carbon 14. Make sure that you pay attention to these things. On the bottom, you should always know where stuff comes because of CRC handbook. This was in 2010 and 2011. Please keep it in mind in this because sometimes the numbers that are in the chart are different than what's in the problems because it depends on when where and when we get this information. Don't forget table O. Table O has the name of the particle, symbol used in nuclear chemistry. What am I trying to answer? Oh, I need to know the symbol used in nuclear chemistry. I go to this table, I see my symbols, I see the notation, I see the names of the notation and the symbols. That's what this chart is telling us. So don't forget, we got the N and O. The no, or the on, the no, right? I know these acronyms are silly, but hey, you guys like the facts and quicks. It's an easy way for you to remember. So if we look here, we have, ta-da, the homework number 4. You had to read all of this. You had to annotate some of these things here. You should be formulating questions tonight. And then you should be doing some research. But just in case you don't know the basic things, uranium-238, that's the mass on top, atomic number. This is the type of decay. This over here tells me what kind of decay. It's alpha decay. If I forget what that is, I go into table O to look for my particles. Oh, there it goes, alpha particles. Symbol used in nuclear chemistry, alpha. When I ask you, what are you studying? You should know you're studying nuclear chemistry. Look at the title. Tonight was nuclear chemistry. The clue was half-life. So if we look at this, half-life of U-238, half the life. So if I have a lot of years, as time goes on, my years or whatever my half-life is, that tells me I'm going to have half left of whatever that substance is. So U-238, if I start with a 100% sample of a substance, I'm going to have half of that, which would be 50. If I have 50, after another half-life, I'm going to have 50% of that, which is now 25. Then after another progression in my half-life, I'm going to have half of that, which is 12.5. So half the life. Half every life, my sample will be cut in half. Here goes my exponential curve. This is the exponential curve to tell you over time, you will lose exponentially the amount of sample you have. And notice that if you look at this time graph, look at how long it takes a long time for these particles to disintegrate. So in this piece here, I want you to look here. This was an example of how to calculate it. One way is a data table. There are other ways we can do this. We can do algebraic equations. But I thought we'd start with a simplistic way where everybody could do the chemistry because you make a table. How much I have, what's the half-life and the time. I go here, I know the amount, I know that I'm going to figure out the half-life from whatever the story is about and the time. So using the half-life and table N, complete this table. So cesium-137, what's the half-life or the time of which it's going to split in half? Half the time, so let's see what the half-life is. Cesium-137, we go down here and we look for the symbol for cesium-137 until we get good where we can look right here and see cesium-137, 30.2 years. And this particular one, wherever we got this information in the past, it said 30.23 years instead of 30.2 years. It's okay. So we have our time. As I increase, I lose a half after 30.23 years. I'll lose another half, double the time, and then the triple time, and so on. So as I'm looking at this, that's how I figure out how much I have. So each time my time extends by 30.23, that's another half-life. There goes my half-life. So I'm increasing by one more 30.23. And as I do that, the amount is what's being cut in half. The amount cuts in half. One whole, half a whole is a half. Now the half of a half is 1/4. One half of another half is 1/8. What am I saying? And half of that 1/8 is 1/16. So here we go. A half of a half of a half of a half. And if I multiply my tops, I get 1. If I multiply my bottoms, I get 16. So that's how it's 1/16. So as I did this chart, I realized that now your answer asked you, what did it ask you? It asked you how much time must go by. How much time must go by to get 1/16. So as I did this, I put the years in. I put the half-lives because if I'm going that way, each one is a half of a half. And then I find the time. At the start, I have a whole piece. Nothing's happened. But as time goes, as the 30.2 years go, I will lose more and more time. And therefore, I will have 4 times that half-life. So there you go. So this would be your answer. Hopefully you understood this. So each of these works on the next page, you should be able to figure this out by using this little table. Or you can make up your own. So simple things like this first one here, right? When I say success criteria, 4 out of 5, we're talking about on the page 1, 2, 3, 4, 5. To get how many out of here? You want to get 4, right? That'll be your 80 with your explanations. So you read it. It says which radioactive is matched with the decay mode. I look for H3 and gamma. I look in here and I try to find H3. H3 is here. What's it? It's beta, huh? Which is matched? That's not matched. Then you just look again. You look K42. And then you look for K42 and B+. Go in here, look for K42. And then you got, is it B+ or B neg? B negative. Don't forget that negative is an electron. These other ones are positrons. So as you go through, you do the process of elimination. How do you explain it? These nucleotides are not properly matched due to the information in table N as annotated or extracted from the CRC handbook. So please, when you do your explanations, explain. Here we go again. What is the nucleotide listed? And its half-life. Find it, K37, and all you gotta do is look for K37. Where's my K37? There you go. 1.23 is what it's supposed to be, and that positron. Where do we have that? K37, 1.24 hours in alpha. So we know it's not that. So you keep going through that, doing the process of limitations and using the guide. So in class, we're going to look at this. These math problems, we will present them. We'll show different ways how to calculate these. And then in tomorrow's video, I'll go over the calculations again. I might use a table or I might just use the algebra. You got to remember, I just love that algebra. So guys, have a good night. Try to work it out. And then in class, where it says worksheet, that's what we're supposed to be doing in class. Discussing these answers with our neighbors. What did you get? How did you get it? What was your thinking? Why did you do that instead of that? Why did you do this instead of this? Not this, not like, let me see your answers and I'll copy them. How did you solve them? This was a little long. I'm hoping you got it.